Welcome back. Today I'm going to show how to debug a CICS program with Trapper, and for that purpose we need a CICS program, of course. And I will use this program, which is get member. It reads a lib member in CICS, and it helps the poor VSE shop to solve the problem of servicing any kind of objects which can usually be stored in a lib member. In COS they have the nice thing of URI maps, but that does not exist in VSE. So this is a small solution to that problem, and we have a look at that program. And what it functions is it functions as subroutine to a COBOL program. The COBOL program calls that via exact CICS link, and and it gets as input, it gets a communication area which has to have some identification, 16 bytes. Then we have the lib member, we have the sublibrary, and we have the member name and the member type. We have a 16-byte prefix for the TSQ and the name of a TSQ. And what that program does is it here we start. It opens libber with the libber DCB function, generates it, and then it opens it, reads the member, and closes it. And it should usually run with without any problem from start to end. If there's a problem, it does not communicate anything to the caller, but instead it communicates to the console. So you better have it right, or otherwise it will be talking to the console all the time. But that's, I figured that passing any kind of error code to the calling COBOL program does not serve the purpose. This is something which must function. So it must specify the correct names, and if the correct names are not specified, it will report on the console, and that should be identified during debugging. Now, what you do with the program, you compile it, submit it to VSE, and you can check the result of this. And we check the result, which is, we have a 0 on the compile, and we can look at the listing. Very end, backward, no statement flagged, and coding. Now, if we would like to use that program, we need to have the communication area set up correct, and I've shown that before, but we'll show it again here. Come on, it's supposed to be, communication area is supposed to be, 2 forward, okay, 16 bytes, and then we have 8 bytes for the library, 8 bytes for the sublibrary, the member name, the member type, 16 bytes Q, and 16 bytes record ID, and then 16 bytes Q ID. All in all, 15 in hex or 80. And what we do is we call that thing with CICS link. For the purpose of testing the get member program, I've written this tiny little COBOL main line, which is just a link to the get member, and sends a message when done. And com area is defined here. Get member PRD2 as library, sublibrary, member type, prefix for each of the records in the temporal storage queue, and the term for storage queue name. Now we compile that, and that's it. Compile went okay, return code 2, and we can now start a debugging session against our get member thingy. Get out of here, get out of here, get out of here, and PF6 and trap, and we would like to test get MBR, and here we have the basic debugger, and we have the plus here, which shows we do have source code available. Press PF11 and we are in source code. Now it's not stopped anywhere because we haven't started the program, so it doesn't know where the break is, but that doesn't hurt. What we do is we put a stop on the very first instruction in that thing, which is here, the store multiple, and the PF keys, if you don't remember them. PF1 shows us okay, so we say stop, and it says trap successful, and that's fine. And now we say go till the trap is hit. Now to hit the trap, we start the test program from another terminal. It could have been done on one terminal, but since we're no longer talking about real hardware, but instead we have the emulation sitting on a PC, and you can have as many emulations as you like. There's no point in going through the hassle of one terminal doing all the interactions. Separate terminals is as good, or even better. So we go into native CICS, and we call the test transaction, which is MTTM, and here we go. It has stopped on the very first instruction. Now we can follow the initialization, but it's no good for anything. But instead we go forward to the first thing we have written ourselves, which is the thing after the end of the macro. We load the length of the COM area, we load the COM area itself, we put some information in we do a work area, and we declare the using for the COM area, and we check that it's long enough. Let's stop on that. Stop here, and PF10 to go there. Now register 4 is loaded with the COM area. Register 1 has the length. Now let's check the registers. You can use R for registers and PF5, or you can use G for grande register, which is the 64-bit registers, or you can use a number from 1 to 9, and then from A to Fox, which indicates you would like to look what is in that register at that location. So first we do an R. That was wrong. Back and R and P5. So here we have the register. So here register 1. Here we have register 4. It's the COM area. And we can look at the COM area. Go with the cursor there. That's one option, and use P5. Okay. Or we can use the 4 here and use P5. It gives the same information. Now, 2 lines is a little short, except when you're showing registers. So what you can do is you can use the trim key here and trim the lower window. So now we have a big area down here. Okay, here's the get Ember and the library and the sub-library. the member and the member type and prefix and queue name. Instead of showing memory, you can also do one thing. Okay, we'll go to the top and we'll go forward. You can go to the using of that for that area. Where is it? Using. Here we have it. You can go to the using, put the cursor on any character of the word using, and use PF5, and it will show you the content of that structure in the structure, which is nice. Okay, we can see we have a name and library. Everything is allocated to the correct location. Okay, so we make that window small again. 4, and we go to the instruction where we are, which is I used B for break, which goes to the instruction where we stopped, or you can use M and PF1 or M PF7 or M and PF8 go to the very bottom, or you can let's go to the top, use whatever you would like to go to, and then the system interprets that as find this label. So if you say what is a label in error, okay, and you press enter, and it goes to that label. Or instead of going to labels, you could go to instructions or to operands of instructions, and you can see all the details in the PDF that comes with the product, which is this here, which has everything in it. But the basic things are PF1, PF2, forward, backward, 7 and 8, and 5, of course. 5, the magic show me something key. Back into the session. Okay, now we want to go to the break. B and PF7. Oh, B and PF7. Come on! Okay. Yeah, and now we can do it step by step and check. Check when remember the PF5. You can use PF5 also here. You can go on that and use PF5, and it says, oh, he wants to see what is in that exact location. So he goes to register 4 plus 20 and shows that. What else can I show? Yeah, I think that is it. And when you're done, you press PF3 and PF3 again, and you can exit with nothing on hook, which is not the truth, and it will tell you there's a program on hook. Use the other one, so we use that one. Oh. Okay, and it comes back to here. It says test complete. So that concludes the show. That is it. Thank you for watching, and that's it. Bye bye.